And we'll start off with a few definitions if you want to highlight them. We call the whole thing, with a square root, cube root, fourth root, we call the whole thing a radical. The little number that's written is called the index of your radical, and the inside is called your radicand. Also important definitions are entire radicals and mixed radicals. And we learned from our activity that when we were adding and subtracting radicals, it was much easier if we could add them if they were mixed radicals. In other words, you saw that 2 root 2's plus 1 root 2 was equal to 3 root 2's, which was much easier than taking root 8 plus root 2 and getting root 18. So one of the things that we're going to want to get really good at is switching back and forth between writing radicals as mixed radicals and as entire radicals. We also learned from our activity that the multiplication property of radicals is just like normal numbers. So if you had a root 5 times a root 20, that's the same as the square root of 100. And if you had a radical, an entire radical to start, like the square root of 54, and you wanted to write it as a mixed radical, you would have to see, is there something that you could break it up so that one of them was a perfect square? How's your times table to get 54? 9 times 6. So because this is 9 times 6, we can rewrite this as 3 root 6. So multiplication acts like normal, but adding does not. So we have these different forms, and we're going to use these different forms to solve some questions. One of the questions that we can solve is ordering them from greatest to least. Some of these are going to be non-calculator questions, and some of these will be calculator questions. Obviously, the calculator questions are super easy. You just type it into your calculator and find out which one's biggest, which one's smallest. But if it was non-calculator, like A, we can change to entire radicals to compare. So I'll start off with 5 root 2. That would equal, well, I could change the 5 to a square root. What number would I put inside of a square root that's equal to 5? 25. And now the multiplication property for radicals says you are allowed to multiply those together. We would get the square root of 50. Now when I compare that with 2 root 5's, here I change the 2, square root of what is 2? To a 4. And when it's an entire radical, I hope you can see that square root of 50 is bigger than square root of 20. And then finally with 4 root 3, square root of what is 4? This would be 16. This is the square root of 48. So if we were doing greatest to least, I would put 5 root 2 is the biggest one. Then the 4 root 3, and finally the 2 root 5. So A is an example of how changing it from a mixed radical to an entire radical lets you compare them. In B, these are all part of the same family. They're all part of the cube root 2 family. And since they're all part of the cube root 2 family, I would not suggest changing them to entire radicals because you don't need to. Does it make sense to everybody that 11 cube roots of 2 is more than 9 cube roots of 2? Okay? Without having to take 11 and cube it. Does anyone know 11 cubed? 1,331? No? Do now. Perfect. And 9 cubed, that's like 729. Those are big numbers. So it is easiest in this one just to say, well, 11 is obviously the biggest one, then 9 of them, and then finally 8 of them. But when you have radicals that have different indices actually, plural, like you have a fourth root, a square root, and a cube root, this is one that we're going to do with our calculator. So the first thing you want to do is you want to take up your calculator and you want to see if you know how to type in 3 times the fourth root of 8. I'm pretty sure everybody is going to be good with 4 times the square root of 2 because you've dealt with square roots before. But also the 3 times the cube root of 5. We want to be able to type these into our calculator. And I'll show you a couple things that you can do with your calculator. If you have a graphing calculator, we'll look at what we can do with our graphing calculator. If you have a scientific calculator, you're going to need to find this as well on your calculator. So first of all, for square root of 2, I'll do the easy one first. Your square root button's right there. You can type in 4 square root of 2. That's going to be 5.6568. But when I go to my fourth root, okay, a couple of things that you could do. 3, on a graphing calculator, if you hit your math button, okay, watch what happens. It has a cube root, it has an x root. So if I go to that x root right now, something interesting is going to happen. It's going to say, oh, we'll put your 3 up there for you. You're like, oh, I didn't want a 3 up there. So I'm going to clear it out again. I wanted to do 3 times a fourth root, so I'm going to hit that 4, and then go to number 5, and it's going to 3 times the fourth root of 8. Push enter, and I get 5.045. I also want to remind you of something that you did in grade 10. Do you remember doing this in grade 10? That the square root of x could be written as x to the half. So another thing that we could do with the fourth root of 8, we could write this as 3 times 8 to the 1/4. Watch what happens when I do that on my calculator. So I'm going to go 3 times 8, hit the exponent button, and the exponent I'm going to do 1 divided by 4. I get the exact same answer. So with radicals, you can change them to rational exponents. If that's easier for your calculator, perfect. Because sometimes that might be nice. So for the last one, I can go 3 times, and under the math button, number 4 already has a cube root. 3 times the cube root of 5, or I could go 3 times 5 to the 1/3. Both of those give me the same answer, 5.13. So listing these ones from greatest to least, the biggest one would be 4 root 2. Second would be 3 cube root of 5. And finally, 3 fourth root of 8. I'd like you to circle 5 and 9. 5 is non-calculator, 9 you can use your calculator.